I will be teaching you about static friction. Personally, for me, problems with static friction in physics are one of the most confusing problems. So today I will teach myself by teaching Amazing Mazes Magnificent Period 12 class. The first step to solving a friction problem is, yes Sandeep, to draw a diagram. I will give an example of a car on a hill being pushed up, since it's one of the most common examples. Firstly, we will assume that the car is just a point for the purposes of drawing. In my opinion, it is first easiest to indicate the normal force, which is perpendicular to the ramp. Then continue by drawing the force of gravity on the car, which is directly downward. Another force on the car is that of the person pushing it up the ramp. However, with the movement comes the force of friction in the opposite direction. Although this is a complete force diagram, it is not very helpful to us since 1, it is tilted, and 2, it does not take into account the components of the force of gravity. So we can redraw this as shown. So just with this representation, we can find many things. Because the car is not accelerating in the y direction, we can set the normal force equal to the force of gravity in the y direction. And the force of gravity in the y direction is equal to the force of gravity times cosine theta, just using trig properties. And as we know, force of gravity is mg. So therefore, the normal force is mg cosine theta. Likewise, the force of gravity in the x direction is mg sine theta. We can also find the minimum force needed to break static friction, or the force of the push needed. So we have to add up the force of gravity and the force of friction, since those are the two forces in the x direction. And the force of friction, we know, is fun, or mu times normal force. And the force of gravity is mg sine theta, and therefore that is the force of the push. Just with this information, we can divide by mass if we know the mass of the car or the object on the hill to find acceleration, and that links us to kinematics, and we can use our kinematic equations to find velocity and anything else that we need. So we just had a question with the force of friction on a ramp, but we're not done yet, because friction was also seen in problems involving centripetal force and circular motion, including the gravitron quiz and turntable questions. Okay, so the first thing we must do again in a problem like we had on the gravitron quiz is to make a diagram. From here, we're easily able to define and understand the forces in the x and y direction. So in the x direction, we have centripetal force going inwards. The same force is also the normal force because there is a force of the surface of the cylinder on the person. Then, as always, the force of gravity is downwards. And you might think we're done here, but no, we're not. Because the person or object moving in circular motion is not moving in the y direction or vertically. So we know that the forces in the y direction must be equal to 0. The only way this is possible is if there is an equal force opposite to that of the force of gravity. And this is the force of friction. This makes sense since there are two surfaces, the person or object interacting with another, or the wall of the cylinder, and therefore friction is present. So far we know that centripetal force is the same as normal force, and the force of friction is equal to the force of gravity. If we set centripetal and normal forces equal to each other, masses cancel out. Also, if needed, we can solve for angular acceleration by knowing our properties between linear and rotational quantities, or the equation v equals angular acceleration times radius. So that ends it for learning about static friction. I know I learned a lot by preparing for this video, and I hope you did too. Enjoy!